Good day. So today we are going to focus on the theorem that is called angle at the center. It says that if you have an angle at the center, that angle is 2 times the angle at the circumference. Okay, so you may have something like this. So let's just say this is our cycle, and then this is our center. This is our center. So let's say this is center O. So this is point A and point B. So what you need to know about the angle at the center is this. If you have an angle at the center and the angle at the circumference, and those angles, they are created by the same points, so therefore the angle at the center is 2 times the angle at the circumference. So meaning that if they are created by the same points, so same points here, it's A and B. If they are created by the same points, so therefore we say that they are equal. So let's say that this one is D. So meaning that if this one is X, this one is going to be 2X. So if ever you have an angle at the center and the angle in the circumference, and they are created by the same points, they are coming from the same points, therefore the angle at the center is 2 times the angle at the circumference. Look at this. Look at this. Both these angles, this angle and this angle D, they are created by the same point A and point B. So this is why we're saying that the angle at the center is 2 times the angle in the circumference. Like it can be anywhere in the circumference, but as long as they are created by the same point, therefore we can say that they are equal. I mean that's the angle in the center is 2 times the angle in the circumference. Like they can be anywhere in the circumference. Even if it is here, even if it's here, let's say it's here, this is C. So this is the angle in the circumference, this one is the angle in the center. But as long as they are coming from the same points, as long as the angle in the center and the angle in the circumference, they are coming from the same point, therefore the angle at the center is 2 times the angle in the circumference. So if this one is 2x, this one is going to be x. So we are saying that angle A, B, we are saying that angle AOB is equal to 2 times angle C, right? Or we say that angle AOB is equal to 2 times angle D, right? So this can be anywhere in the side in the circumference. As long as the angle in the center and the angle in the circumference, they are created by the same point. So we can say that they are the angle at the center is 2 times the angle at the circumference. So let's say this time it's here. I'm drawing one bit here. Let's say it's here. So this one is E, right? So as long as they are coming from the same point, as long as the angle in the center and the angle in the circumference, they are coming from the same points. So therefore we say that the angle in the center is 2 times the angle in the circumference, meaning that we say angle AOB is equal to 2 angle E. Angle in the center is 2 times the angle in the circumference. So it's like this, angle at center, right? So it's like this. If ever they're coming from the same point, so they're like this. Okay, but then let me show you the proof, because sometimes you might be required to do a proof that the angle in the center is 2 times the angle in the circumference. So let's do a proof. Let's do a proof. Let's look at this one. Let's look at this one. In the diagram below, D is a center of a cycle ABC with the radius BD produced to O. Okay, let me draw this one. Let me draw this one. My drawing is too bad, but then let me try it. Okay. No. Drawing. Okay. Yes. Now it's right. Okay. Let me draw it. So this is the center. Right. So they marked as. So here we have a line. This is point D. This is A, B, C. Right. What else? So then this one is O. And then we are to use the diagram to prove that ADC, to prove that ADC is equal to, so actually we are required to prove that ADC is equal to 2 times ABC. We are required to prove that. Okay, so the first thing that you can do here, let's just name the angles. Okay, let's just say let angle ABC, I mean ABD equal to X, and angle CBD equal to Y. So meaning that this one is X, this one is Y, right? And then what else do we know here? We know that BD is equal to DC equal to AD, that is in Sarah D, right? So meaning that we can say that angle A is equal to angle A, B, D equal to X, that is in opposite the reason is the angles that are opposite equal side. So the reason angles opposite equal sides, right? AD is equal to BD, meaning that this is an isosceles because two sides are equal. BD is equal to AD. You say that BD is equal to AD. So meaning that you can say that angle A is equal to angle ABD because angles opposite equal sides, they are equal, right? So if it's like that, then we can also say that this angle, we can also say that, so now this one is X, we can also say that this angle ADO is equal to angle A plus angle ABD. That is in the exterior angle of a triangle. Exterior angle is equal to the two opposite interior angles of the triangle. So meaning that ADO is equal to angle A plus angle ABD. That is in exterior angle of triangle ABD. The exterior and angle that is outside the triangle, the exterior, is equal to the two opposite interior angles. So meaning that ADO is equal to 2x, because angle A is x, angle ABD is x. So x plus x is equal to 2x. And then now we can also say that angle C is equal to angle CBD equal to y, right? That is in angles opposite equal sides. So again, this is also an isosceles triangle. This is also an isosceles triangle. Triangle CBD. This is also an isosceles triangle. BD is equal to DC. The reason these are these, right? So meaning that if these are equal, this is an isosceles triangle. So meaning that this angle is equal to this angle. Isosceles triangle. Angles opposite equal sides, they are equal. So, and then, so meaning that we can now say that angle CDO is equal to angle CDO, this angle, the angle that is outside this triangle. The angle that is outside this triangle is equal to angle C plus angle CBD. The reason this is an exterior angle. Angle CDO, this is an exterior angle. The exterior angle is equal to the two opposite interior angles of a triangle. So I don't know if you remember this, but usually something like this. You have a triangle. So this is C, this one is A, this one is B. So what you should know is that an angle which is outside the triangle, the exterior one is equal to the two opposite interior angles if you add them. Right? Okay. Let's continue. That is in the exterior angle of triangle CBD. Right? Now, so meaning that you can say that angle CDO is equal to 2y. The reason we know that angle C is y and also angle CBD is y. So y plus y is equal to 2y. Right? Now, let's continue. So now, so this means that we can now say that ADC is equal to ADO, this angle, plus CDO. So ADC is equal to ADO plus CDO, right? So ADC is equal to ADO. We know ADO is 2x plus CDO is 2y, right? So if you can check here, we have a common factor of 2. So if we take out this common factor, we're going to have x plus y. So ADC is equal to 2. Now, if you can check x plus y is this angle. because this portion is x, this portion is y. So meaning that x plus y is equal to ABC, is equal to angle ABC. So meaning that therefore we have proven that angle ADC is equal to 2 times angle ABC. We have proven that. Okay? So if ever you're told to prove, you must prove it like that. Thank you so much. Please subscribe.